Good day, and welcome to another episode of my reviewer series for civil engineering topics focusing on fluid mechanics problems. In this episode, a vertical cylindrical tank has a diameter of 1 meter and a height of 2.5 meters. The tank, open at the top and is 3/5 full, is rotated about its vertical axis at a constant angular speed. Given this condition, we are to answer the following. At what maximum angular velocity must the tank be rotated so that the contents do not spill? At what minimum angular velocity must the tank be rotated so that the bottom of the tank becomes exposed? And at what angular velocity must the tank be rotated so that the diameter of the exposed surface at the bottom of the tank is 40 centimeters? To start this, let's familiarize ourselves with the formula used for determining the angular velocity. Given the equation y equal to lowercase omega squared times x squared over 2g, this represents the relationship between the parabolic behavior of a fluid surface when subjected to irrotational speed inside a cylindrical container. So, what does this mean? Explain muna natin. Upon observation, mapapansin natin na kapag may actual rotation yung fluid sa loob ng tank, nagpo-form to ng palubog na figure sa gitna, while sa gilid umaangat naman siya. In this scenario, nabubuo yung tinatawag natin na paraboloid, or yung parang parabolic figure na generated when subjected to rotation. Relating this to our equation, y is just the height of the formed paraboloid. Omega naman is the angular velocity of rotation, x is the horizontal distance from the axis of rotation, meaning center to point of circumference lang, and g is the acceleration due to gravity. Now that we are familiarized with this, proceed na tayo sa pag-perform ng solution. Solving for the first problem, i-transform muna natin yung figure based dun sa condition na nasa question. So given na di dapat mag-spill yung contents, sagad lang natin yung paraboloid ng fluid sa loob up to the height ng tank. Then supposedly, di magbabago yung volume ng fluid. We are also made aware that the volume is 3/5 of the tank. Therefore, given na yung height ng tank is 2.5 meters, and all throughout sa length ng cylinder is uniform shape lang naman siya, we can determine the height of the fluid just by getting 3/5 of the tank height. With that, ang initial height ng fluid natin is 1.5 meters. And we can also say that the depth of the void in our container is 1 meter. Moving on, when it comes to the paraboloid of a fluid being formed within a rotated cylinder, it is useful to take note na yung angat ng fluid on its sides, when rotated, is just equal dun sa height ng lubog na mapo-form sa center ng paraboloid natin. Technically speaking, yung center height ng paraboloid natin is just the height ng fluid pag naka-steady position ito. And now that we are given that idea, we can say na dahil yung angat ng fluid natin is just the height of the void inside our container, yun lang din yung magiging lubog ng paraboloid natin. Therefore, the height of our paraboloid is just 1 plus 1, which is equal to 2 meters. Now, using the formula, plug lang natin yung 2 meters natin sa y value, then sa x naman, this is just the radius of our circle na formed sa pinaka-end ng paraboloid natin. And since alam natin na yung diameter ng figure is 1 meter, we can say that the value of Rx is just half of it, which is 0.5 meters. Lastly, para sa G value, as we all know, standard lang na 9.81 meters per second squared ang gagamitin. Plugging in this numbers equation, then shift solve sa calculator, we will get a value of 12.528 radians per second. So another thing to keep in mind when utilizing this formula, dapat yung unit ng angular velocity natin is always in terms of radians. So if ang required answer natin is in RPM or revolutions per minute, 1 revolution is equal to 2 pi radians, and 1 minute naman is equal to 60 seconds. To convert our answer, multiply lang natin to by fractions of equivalent conversions in such a way na pwede natin makancel out yung initial units. Just then, we will get 119.637 revolutions per minute. Now, to be honest, nung time na nagsasagot ako ng ganitong problems, lagi kong nakakalimutan kung paano yung direct conversion from radians per second to revolutions per minute. Pero fortunately, nakatatak na sa utak ko ever since yung conversion ng radians into degrees. Kasi yun talaga yung isa sa mga unang conversions na naaral natin from geometry pa lang eh. Pero paano nga ba ito naging relevant sa conversion na hinahanap natin? Kasi diba, ang isang buong ikot is 360 degrees. And at the same time, ang isang revolution naman is obviously isang buong ikot din. Therefore, 360 degrees is just equal to 1 revolution. And since alam ko na 1 radian is just equal to 180 degrees over pi, nirelate ko na lang lahat ng conversion values nito into the following expression na makikita niyo sa screen. Simplifying yung mga gagamitin natin pang convert, we would still end up having 60 over 2 pi as our multiplier. So, na-share ko lang para just in case, mas madali yung matandaan yung logic ng conversion. Pero moving on, proceed na tayo sa second problem. So, ang hinahanap is yung minimum angular velocity given the condition na dapat exposed na yung bottom ng tank natin. And since mas mababa na yung position ng paraboloid kesa sa kanina, masasabi natin na bawas na yung volume ng fluid na nasa loob. Pero putting that fact aside, ito na yung pinakamadaling question na masasagutan natin. Kasi for one, yung y value or height ng paraboloid natin is just the height of the cylinder itself. And two, seen pa rin yung x value na gagamitin natin, which is yung radius ng cylinder. So plugging in our known values, ang makukuha nating angular velocity is 14.007 radians per second. Converting it to RPM, similar sa method na ginawa natin kanina, we will get the final answer of 133.758 revolutions per minute. For the last problem, ang required condition naman natin is dapat merong 40 cm diameter exposure sa base ng tank natin. And how to approach this is just by considering another unknown variable, which is yung height ng imaginary paraboloid na magfo-form sa base ng tank natin. So let's denote that as y sub 1. Based sa condition, dalawa na yung unknowns natin, which is angular velocity denoted as omega and y sub 1. Therefore, we'll have to get two equations from this problem to solve for the two unknowns. And to do that, start muna tayo sa usual na pag-solve na ginagawa natin. Using the formula, yung height ng buong paraboloid natin is 2.5 plus y sub 1. Then x value of 0.5 kasi radius ng tank natin. So, masiset na natin yung first equation natin. And to make it more convenient, let's express this in terms of y sub 1. So, transpose lang natin yung 25 natin pa kabila. For our second equation naman, mag-reference lang tayo from the bottom of the paraboloid up until sa bottom lang ng tank natin. Therefore, yung y value natin is just y sub 1. Then yung x value naman natin is the half of 40 cm, which is 20. Then, take note, lagi dapat similar units ginagamit natin. So, convert natin to into meters and we will have a value of 0.2. With that, and yung standard value rin nga pala natin for g, which is 9.81, we are now able to write our second equation. And equating equations 1 and 2 with each other, since pareho naman silang in terms of y sub 1 na, we are able to get the value of 15.283 radians per second. And applying yung conversion method na ginawa natin kanina, this is equivalent to 145.942 revolutions per minute. If you have any further questions, just feel free to ask in the comment section. And with that, this situation is now finally solved.